I may welcome Kydyraliev from Google security team, who will give us a talk about security in Java frameworks. And I think it's not exactly about security, more how to get in, right?
Right.
Yeah. So let's see how you can get into modern Java frameworks.
Yeah. Hi. So yeah, the title is "Milking a Horse or Executing Remote Code in Java Frameworks." And the idea is that if you thought that neither of those two things were possible, then you are wrong. So to get the milking horse part out of agenda, right? So you may wonder, why would you want to milk a horse in the first place, right? So in reality, in Central Asia, in the region where I'm from, we actually make a drink from fermented horse milk. And an interesting thing that when you milk a horse, right, you cannot just come up to a horse and start milking it. What you have to do is you have to bring a baby horse to start sucking the milk, and then you move the baby horse away. And while it's still touching the horse, a human comes and starts milking. So horse gets owned a little bit, right? Gets tricked, and its ambient authority is abused. Confused deputy problem. Anyway, back to security. So web frameworks. Web frameworks have evolved a long way, right? I don't know, how many of you have actually written Java code ever? Oh, sweet, a lot of you. Good. So in the beginning, right? In the beginning, when we used to write servlets and we used to write some code, what we do is we would actually take a servlet, we create a do-get, a do-post method, and if we need to produce some HTML, so what we do is we simply spit out the HTML right on the output for the connected socket, right? At some point, we realize that it may not be the brightest idea, because what we have to do now is we have to write a lot of custom code if we want to customize our front end, right? So what we got now is we got JSP, or Java Server Pages. So the way things are happening now is you create an object, you do all of the things, your method gets executed, you perform all of the things, and then you pass the object down to a page, like a JSP page in this case. The page retrieves the object that you've sent to it and shows that object to the user. The cool thing about this is that JSP in general provides you with a way to create custom tags or custom tag libraries. And those custom tag libraries allow you to produce different output based on different criteria. So you can have the same JSP page, but for a mobile version, it's going to display a mobile version of your website, and for a normal version, it's going to display a normal version. As you can see in this code, there are a lot of problems that arose from this. What we've realized is that what we're doing is we're writing a lot of boilerplate code. So because you're getting all of the HTTP parameters from a HTTP request as strings, if you want to do any sort of conversion, or if you want to store that data as an integer or any other data type, what you have to do is you have to actually perform manual conversion of those things and handle exceptions when your input does not comply. In addition to that, input validation, right? So if you have an object and you get an integer, a string which represents age of a user, what you have to do is you have to convert that to an integer and then perform some comparisons to make sure it's not negative and not 2 million years, right? And in addition to that, if you want to have clean code, and you want to pass around objects as opposed to strings, what you have to do is you have to create an object. For example, if you have a form that represents your profile or user's profile, once user submits that form, you have to create an object called user. You have to get all of the values, convert all of the values, set all of the values on the object, and then start passing this object around. So as you can see, that there's a lot of boilerplate code that we don't want to write, and it's always the same. So what modern frameworks did is they came and they said, hey, how about this? We take back all of these boring tasks of converting things and setting things and validating them. And what we're going to let you do is write simple POJOs. That means you simply write a Java object which does not extend any interfaces, which doesn't implement any magic methods. It's a simple class, maybe with an annotation that says that it's a controller class. And frameworks will do the rest. If you think about it, all of the complexity that you had to do, all of the complex code that you had to write yourself, such as conversion, validation, and construction of objects, had to be done by someone. So the complexity moved from your code into the framework code, and it actually became even more complex Because what frameworks had to do is they had to make it generic and make it work with every class and different hierarchies. So they use things like reflection very heavily to make sure that they can enumerate dynamically what kind of object you got, what's the type of the object, and construct and validate it accordingly. If I had to summarize the current state of a Java enterprise development, this slide would summarize it. Half of the abbreviations on that slide I don't actually know, but there are so many technologies. In a simple Hello World application, you can have megabytes of jar files, which all do a lot of crazy things just to print something simple out. So the question is, how secure are those frameworks? So we have a lot of code, and as we know, the more code you have, the more vulnerabilities you have in that code. So looking back at the history of vulnerabilities in Java frameworks, we see that in addition to some not very serious XSS vulnerabilities in directory traversal, there was one vulnerability in struts which was actually interesting, which had to do with validation. So if you had a text field, and inside of the text field, you entered OGNL statements, and I'm going to talk about OGNL later on, but for example, you entered a special marker, and then 1+1, and you submit the form. If the value does not pass the validation, error page is going to be shown, and your value is going to be shown back to you saying, oh, this is an invalid value. And if you entered OGNL statement 1+1, the value that you're going to see there will be 2. So the statement that you entered, if it failed validation, would actually get executed, which effectively was remote code execution in struts. That was the only serious vulnerability that was discovered. And Spring had some not very interesting remote denial of service. So what I've done is that I've taken 3 most popular frameworks, which are JBoss, JBoss SIM, Apache Struts, and what was the third one? I forgot the third one. The name of the third one. Third framework. What I did is I took IntelliJ, which is a really great IDE for Java. And the reason why you want to use an IDE is because modern Java code and Java programmers in general are really obsessed with having your testable code, meaning that when you have your code, what you pass around are actually interfaces with no implementation, and you can have 2 or 3 implementations. And what happens is a thing called dependency injection. And at runtime, the people are injecting specific implementations of those interfaces. And a lot of times when you audit an application, you will look, oh, what is this code? You go to the definition of that code, and you see it's just an interface, and you can only see 3 or 4 implementations, and you don't really know which implementation is used when. So IDE helps you do it, at least navigate all of this code faster. Debugging also lets you quickly dump all of the mappings and see which implementation is used exactly when the application is running. I took a sample application, so usually each framework supplies you with a sample application which tries to show as many features as possible, which guarantees pretty good coverage of features. And each vulnerability took about 5 man-days to find and exploit fully. And what I focused on is at the magic, right? What I focused on is how the framework is doing all of those things, why developers love those frameworks. So conversion of things, automatic construction of object, validation, and all those things. So let's look at Apache Struts. How many of you use Apache Struts? Really, no one? You're just scared, right? Sweet. So Apache Struts gives you it's a really popular framework, actually. A lot of big companies like banks that I've seen are using these frameworks. So it has a cool rich tag library, which allows you to create a fancy custom tags. Like this is an example of provided custom tag, which performs AJAX requests for you the minute user clicks on the make request thing and populates the div above automatically. But another cool thing that it has, and why a lot of people love it, is OGNL. OGNL is Object Graph Navigation Language. And what it lets you do in this particular case, inside of the tag, instead of actually calling methods and objects directly, what you can do is you can write the following. You can write #session.user.username, or inside of HTTP parameters, what you can do is you can do user.address.city. And if we're going to look at what it gets converted to, it actually gets converted interestingly into the following. So if you do user.address.city, city in HTTP parameter, what it gets directly converted to is action, which is current action that handles the code, .getUser, .getAddress, .setCity automatically. And in the other case, it gets converted to retrieving session context and getting the username attribute from the session. So it's very interesting. So in addition to that, OGNL, which is an ANTLR-based parser, which is actually important for this vulnerability, provides you features such as I've shown, property setting. So you can do foo.bar equals buzz, which becomes action.get foo.setBar. It provides you with an awesome feature of calling methods. So you can just simply call a method with parentheses and pass arguments to it. You can call static methods too. So this is an example of how you would call a system.exit. And it allows you to call constructors. So you can actually arbitrarily construct arbitrary objects passing arbitrary arguments to it. And it allows you to save things into context variables. So in the last example, what we take is we create a myClass object and we save that instance into a foo property. Now you may wonder if HTTP parameters are actually OGNL statements, why you cannot do something like this, right? Why you cannot simply call victim.foo, whatever is the action handler, and simply pass OGNL statement at Java lang system at exit and then parentheses, right? In reality, you can, or you could. The thing is that what prevents this is two variables that actually prevent you from doing this. One is called, it's actually a property in OGNL context, which, as you can see, is called denied method execution. So if this value is set to true, then any method right prior to executing your method is going to parse your input as a method, but right before executing it, it's going to go and check whether the property allows you to execute method. And if it doesn't, it's going to throw an exception. And another thing, if you want to access static methods, such as Java system.exit, or more interestingly, runtime.exec, which allows you to execute operating system commands, since it's a static method, well, obtaining runtime, for obtaining runtime, you need a static method. There is another private field called allow static method access, which is also set to false, right? So these are the two things that actually control the execution of methods. So a vulnerability is actually based on my previous vulnerability that I discovered. And in OGNL, what's important is this hash sign. So the hash sign actually represents in OGNL a reference to so-called context variables. And there are a lot of interesting context variables. As you can see, one of them is session. So if you can reference to hash session and then simply put square brackets and some string in there, what it's going to translate into is getting session and modifying server-side session attribute and setting it to something, right? In your code, in applications, a lot of time when you can do that, you can probably log in as another user or elevate your privileges by changing, I don't know, the bit that tells that you're an admin. If you look, there are a bunch of other so-called attributes, such as parameters and attributes. Now, what stops you from submitting code, just an HTTP parameter, and saying hash session and modifying things, is a thing called parameters interceptor. This interceptor is actually the one responsible for processing all of the OGNL statements. And what it does, it actually blacklists the hash. So it simply looks at the HTTP request and it says, oh, there is a hash, simply ignore this HTTP parameter. So this XWork641 vulnerability was due to the fact that it was an ANTLR-based parser. And in Java, I don't know if you know, there is a notation where you're allowed to represent characters using /u and then the hex value of the character. So in this particular case, 23 is the hex code for a hash. So in this case, if we do this, as you can see, I use a concatenation. If you do concatenation, it actually results in this being actually translated correctly into hash. And this way, what it's going to get translated into is session user, and then the next one is going to simply get session and put attribute user with your value owned, right? When I report this vulnerability, the way they fixed it is they simply cleared the value stack. What it means is that none of the values I set will actually persist. So I modify stuff, but it still gets deleted and erased. And I left it at that. I figured that was insufficient fix because they should actually fix the bug, underlying bug of the fact that I can bypass that, but they didn't. After that, about a year later, I finally got around to come back to this vulnerability, and I looked inside of the OGNL code. So a little bit about the OGNL. OGNL is this unrelated third-party jar file which was maintained by someone but is no longer maintained. No one knows what's going on inside of the jar file, and a lot of frameworks use it. At least 2 frameworks were using it, and the way they use it is they simply get the jar file, get source code, and they maintain it. And by maintaining, I mean they probably fix bugs and stuff, but no one deeply understands what's actually happening inside of OGNL. So I looked inside, and you know how there were a bunch of variables that I showed you previously, like application and all of that? There are actually a lot more internal variables if you look at OGNL code. If you look at them, one is context, one is member access, root. And remember I told you that there are 2 variables that control method execution? One was OGNL context, and one was a secure member access. And if you look here, there they are. So what happens now is that it turns out that using my trick, using /u0023, we can actually modify 2 very important variables inside of OGNL context and secure member access, and effectively disable all of the method execution checks and execute methods just from the URL parameters. So a simple exploit for this would be as following, right? Hash context, deny method execution equals false, allow static member access equals true. We can, because the full exploit will actually look as following. So we do allow static method equals true. It's gonna take, okay, here. It's gonna assign and modify the private member and set it to true. Next, what we do is we actually need to, because when code checks whether you can execute methods and it takes the value, what it does, it casts it to Boolean. And since we're operating on strings, when we set this, excuse me, set this attribute in the map, it's actually set as a string. So when they cast, if you cast string into Boolean, it throws an exception since you cannot do that. So the way we bypass it is by using awesome features of OGNL, such as arbitrary object construction and context variables. So what we do is we construct Boolean class, assign it to foo, and then since it represents false, and assign that to the attribute, and cast checks pass immediately. Next, what we do is simply obtain runtime and call runtime.exec, and you execute effectively operating system commands. The full exploit looks like this. I have to use a lot of expression evaluation, this parenthesis features of OGNL. And what it does effectively is it creates a TMP directory called pwned. And when you see this is actually, that's what you enter in your browser, right? You enter in your browser, you hit enter, and you execute operating system commands there. Interestingly, when I reported this vulnerability, it took a Struts framework, which is actually an open source framework under Apache. It took them 3 months to fix it. And the reason for that is apparently Struts, and I think some other projects too, what they do is they have so-called council, Apache Struts Council. And when you fix something and you want to release, this council has to actually vote, and you have to get 3 or 4 binding votes that will okay the release. And for whatever reason, at that time, some people were on vacation, some people were gone, some people were simply ignoring the emails. When the person who fixed the vulnerability and finally cut the release and wanted to release it, it took them 3 months effectively to vote on it. And I kept emailing everyone. I kept telling them, hey guys, this is actually pretty bad. It's pretty serious vulnerability. It allows by default to execute everyone arbitrary code. And they kind of ignored it, and then they finally got around to it, and yeah, after 3 months. So much for open source security. But at the same time, you could actually work around using exclude parameters, attribute of parameters interceptor. So you could actually supply regular expression to blacklist the following characters, and it would actually make the bug impossible to exploit. Any questions about this vulnerability? Yeah, it's pretty straightforward. So Spring MVC is another framework whose name I forgot. So Spring MVC is a very complex framework. They have a lot of stuff. You can write rich clients. You can write a lot of things. And the web component of Spring is called Spring MVC. MVC stands Model View Controller. And interestingly, they use a Java Bean API. It's an API which is provided by the JDK to work with beans. What are beans? In Java, beans are simple objects which have set and get methods for attributes. So you can have a bean called person, which will have first name and last name. So if you have two methods for each attribute, such as get first name, set first name, and get last name, and get set last name, the properties that will be returned for this particular object would be first name and last name. So introspection API provides you, if you look at the definition of the introspector, it provides you with two methods. One of the methods is get bin info, and you simply pass the class, and it returns you bin info. And another one is when you pass, also in addition to the class, you pass a so-called stop class, which means once using reflection, it's going to hit this class because it does it recursively. It looks at the parent class, and the minute it hits the stop class, it's going to stop looking for more properties. Now, a lot of people, the way they use this code is just by calling get bin info and simply supplying the class, and that's it. And if we have the following object, such as person, as I said earlier, first name, last name. If we're going to call get bin info on the person class, what it's going to return is it's going to return first name, last name, which are expected attributes, right? Because that's what we have created in this object. But another attribute it's going to return is attribute called class. And when you see it, you kind of like, yeah, class, yeah, whatever. But then, if you look at it, class actually belongs to an object, right? Every object in Java actually inherits from object eventually. So object belongs to class and corresponds to get class method that every object in Java has. So if you submit and you go further, if you submit a request which is class, dot, and foo, something random, and you break in the debugger there, and you can see what kind of attributes class returns, you will see that one of the attributes it returns is class loader. And this class loader attribute corresponds to get class loader method. Now, if you go further and do class dot, class loader dot, and then look at all of the other properties that it returns, you will see that there is working dir, there is anti-jar locking, there is jar pass. All of those correspond to either get or set methods. So, for example, urls corresponds to a method which is called get urls. Interestingly, the urls method returns an array of urls in the class loader. Now, so what happens is that because of the incorrect usage of APIs, we can submit an HTTP request as following. We can simply do class.classloader.urls 0 equals and the path to a file. Now, you may wonder, oh man, you're using a square and a 0. Why is it like this? What's taking care of everything? Well, framework is doing all of that in the background. When you refer to URLs, it's going to retrieve the getURLs method. It's going to look at the return value. It's going to see that it's actually an array. It's going to invoke special handler for array. It's going to parse our square brackets and index, and it will actually handle all of the magic underneath for us. We don't have to worry about it. It's part of the framework. Unfortunately, this path is not actually used to look for classes. The way in Java class loading works is that when you request class which has not been loaded, what happens? It goes and tries to find that class. Well, when we modify the path here, this path is not actually used to look for classes. But it turns out, after a little bit of searching, that Jasper is a JSP page compiler by Apache. What it does, it actually, when it tries to resolve TLD files or custom tag libraries, it's going to use our URL to resolve and look for them. So there are two problems here. A, we need to figure out how to execute arbitrary code using TLD files. And second is, how do we supply a remote attacker-controlled TLD, right? So how do we execute code? The way it works in Java is a TLD file, as you can see below here. What TLD file does is TLD file defines tags and tells you which code handles those tags. And when you say which code handles those tags, you can specify either a class name or you can specify a tag file. And here's what we do here. We say that input tag in the GSP page is going to be handled by /metainf/tags input.tag. And what Jasper is going to do is Jasper is going to go open that file and execute it because tag files are effectively just simple Java text files. So you can actually supply arbitrary Java code inside of those tag files. So this is our sample tag file. So boom, we solved the problem of how to execute code remotely. We can do it via tag files and via TLD. How do we supply remotely an attacker-controlled jar? Well, it turns out that inside they use a URL class. And in Java, the URL class is actually capable of doing a lot of things. And one of the things it's capable of doing is that if you supply that URL right there, jar:/HTTP attacker spring form TLD, what it's going to go is it's going to transparently for you go send an HTTP request to attacker's host, retrieve the jar file, open the jar file, unzip the jar file, and for you it's going to happen absolutely transparently. The code doesn't know that it's dealing with remote code. And interestingly, the tag files, the ones I've shown you earlier, are retrieved from the same jar file. So the full exploit for this would actually look like this. We download the Spring servlet code, and inside of that servlet code, we have a TLD file for all of the Spring form tags. So things like form input, form text field, form. What we do is we edit the Spring form TLD file. We modify all of the tags to point to our input tag file. We create the following input tag file, which will simply execute our arbitrary code. We bundle back everything together into Spring form jar. We put it on attacker's host, and then we submit the following form request, which gets parsed by form controller. We override the URLs, and next time, when someone requests a JSP page which has not been compiled, what's going to happen is Jasper is going to go and start looking for the tags that they're using, and it's going to try to resolve those tags. And when it's going to try to resolve those tags, it's actually going to go and look into one of our URLs to try to resolve it, and we're going to give what it wants, and boom, our code's going to get executed. The way you do and the way you correctly fix this, right, at least that you would think so, would be by supplying a stop class, like in this case here. So we say, oh, get us bin info and person class, but stop at objects. Don't show us any object attributes. Guess how they fixed it? Spring simply blacklisted class.classloader. Right? Instead of specifying that, and I asked them why they did that, they said that because sometimes people want to access a class name using class objects, so they do class.name. So obviously the question is why you couldn't just whitelist that as opposed to blacklisting that. But anyway, that's the approach they took. They very quickly fixed this vulnerability. Interesting thing about this, if you do code search for this, it's a very common pattern, and a lot of code does it. So Jasper, I don't know, in JSP pages, you can have a set property attribute, which allows you to do the same, set arbitrary properties. They use this API incorrectly. Pretty much most of the frameworks I've looked at, they use this API incorrectly. So yeah, if you use this code, make sure you use it correctly and specify a stop class. Any questions about this vulnerability? So yeah, there's got to be a better way to exploit it than waiting for uncompiled JSP pages, but I'm sure it's possible when someone will look at it. JBoss-sim, very interesting bug. So before we actually proceed, quick introduction into reflection. So what reflection does, in Java, reflection allows you to look at the class, obtain a class that represents that class, well, represents that object, and enumerate all of the methods, all of the fields that this class has, so that you can arbitrarily invoke arbitrary methods. You can even access private fields and do a lot of crazy things with reflection. In this particular case, we take the string class and we look for a method called length, and as you can see, we do class.getDeclared method length. What getDeclared method returns is a method instance. And if we want to invoke that method, we simply do lengthMeth.invoke. As a first attribute, we have to pass an instance on which to invoke that method. In this case, we say, oh, invoke it on the string instance we have constructed above. It's going to invoke it and return you the value which you cast to an integer, and you get it. Very simple. Well, it is pretty simple if you look at it. Here, JBoss-sim, another very popular framework. It combines EGB3 with JSF, whatever that means. Then what they do is they use POJOs. So that means what you do is you don't write servlets anymore. What you write is you write controllers. So you write simple Java object which has a method that does something, and you annotate it. You say, oh, this is a controller at this path. And a framework is going to automatically discover all of your controllers upon loading. So you don't have to create any of the configuration files saying, oh, this class does this and this class does that. It automatically discovers it. And an interesting thing it has a JBoss unified expression language. So remember we had OGNL in struts? So here they actually created their own. And the minute you see custom expression language in the framework, this is the first thing you have to look at, because chances are they used it so extensively that they forgot the trust boundaries at some point somewhere in the code. JBoss expression language, here's how expression looks like. So you provide a hash and then a curly brackets and you put your expression in there. Supports method calling. So you cannot simply randomly call methods like Java lang runtime, get runtime, because the object you're calling it on has to be actually defined or predefined. So there are several predefined objects like requests, sessions, and etc. As usual, it has container support. So if your method or your call returns any sort of container, be it an array, a map, a list, excuse me, anything, they're going to automatically index it and support it for you and do all the magic for you. So it turned out, after looking and stepping through the code, it turns out that there is a special parameter called action outcome. And if this parameter action outcome starts with a slash, then it kind of denotes a relative URL. And then every value of the URL that you supply, every HTTP parameter value of the URL you supply is going to be so-called interpolated, meaning all of the JBoss expressions that you have in that URL are going to be executed for you. And this is external HTTP parameter. So let's say we want to execute this particular expression as an example. First of all, we URL encode it. After this, as I said, it's HTTP parameter values. So we create a parameter called pwned equals and then that value. And then as follows. If we submit this request, so slash and whatever SIEM application handler, then we do action outcome slash and then the URL and HTTP parameters, our code gets executed. Now the question is, how can we execute operating system commands in this case? Because it appears as if you can only call methods on the predefined objects. So you cannot simply call Java lang runtime because class Java is not actually registered as a predefined object. So it turns out that there is an awesome feature in Reflection that once you obtain class, and every object has a getClass method. The class object has a method called forName, which returns you another class instance. And to forName, you can pass arbitrary class names. So and the line below there, you can see we do view.getClass.forName Java lang runtime. And this way, we actually get access to the runtime class. Once we get access to the runtime class, I showed you earlier, we need to find corresponding methods of the inside of the array that we want to execute. So the exploit will be as follows. We call Java view get class for name runtime. Then we do .get declared methods. Once we get declared methods, what it does, it actually returns an array of methods. Once the array of methods is done, what we do is we simply index it. We say 19th element in the array returns by get declared methods, and we simply call invoke. And it will invoke the 19th method of the runtime class. If you execute static methods, you don't need to provide instance. You can just provide now. So that's what you do when you get a runtime instance. Now, so in this particular case, in order for us to call Java lang runtime exec, we need to do two things. We need to obtain a reference to runtime, because exec method is actually not a static method. It's an instant method. But the way we get runtime is by calling a static method, runtime.getRuntime. I know it's confusing. Anyway, so you may wonder, so how do we know all those indices, right? How do we know that exec method is at index 19, or it's probably different between OSs and different versions of Java? It's actually cool because you know what's the point of this feature it probably is when you specify action outcome so that you could redirect user to a page that is, say, specific to them. For example, if they have organization ID, you can dynamically retrieve organization ID by using JBoss expressions such as org ID, for example. So if we call this, what's going to happen is that we're going to get actually redirected because that's what it's supposed to do. It's going to say, oh, action outcome, sweet. Oh, you want to redirect to sim booking pwn.xhtml? Sweet. The parameter is pwn equals, and here's the output of the JBoss expression that you supplied. So in this case, it's simply two-string call for the method. So in this particular case, the method, if we refer to 19's method, by just looking at the output, what can you tell me? It's an exec method, right? And the argument that it takes is a string, exactly what we want. String is operating system command. And by redirect, I mean just redirect in the browser, right? So the full exploit for this is like this. So we do get runtime, we call 19's method invoke, and then inside of that, we need to pass an argument, right, to a runtime instance on which to invoke the exec method. So this will make it more difficult, slightly easier. So first we obtain call the exec method, but then because exec is actually a non-static method, we have to pass an instance. So what we do is we call a get runtime method. And as you see, I pass null to invoke because A, it doesn't take any arguments, and B, it's a static method, so it doesn't need an instant. And the third argument is simply a command that we want to execute. And that's it. You supply it on the URL. This is the full exploit. So you simply do sim. Sim booking is a sample application that comes with sim. You do home.sim action outcome, specify your URL, and do it. And I'm going to show you a demo. Demos are not very impressive with vulnerabilities like this, because all you do is just simply enter a URL. So I copied. So first of all, to make sure I'm not lying, we ls-l tmp pwn, there is no such directory. Then we go here. I enter the URL. As you can see, it's a command, just like I showed you in the previous one. We call mkdir pwn, get declared message 7, la la la. We hit enter. What we get in return is, as you can see, we get redirected to our URL, and what you see here is a two-string output of what was produced. When you call exec method, what it returns Unix process class, because it executed operating system command, and that's what we got. We got a Unix process right here. And then we call ls-l, boom, the directory was created. So code was executed from the browser. And as I said, it's not very as impressive. Sweet. So what does it tell us? It tells us that Java vulnerabilities are kind of complex, right? That there is so much code, and we've assumed that because it's Java and it doesn't have inherent problems like, for example, C and C++ applications where you need to worry about memory management and bounds checking and all of that. With Java, we assume that the worst thing that can happen is XSS vulnerability, XSRF, maybe some access control issues, but we kind of assume that no one is going to pop a shell in your application and then own you, right? Luckily, unlike other languages, Java, thanks to the way it was originally designed and what it was designed for, applets, Java applets, it has a feature, a facility called Java Security Manager. What Java Security Manager is effectively a singleton which you set on all of the runtime. So you call system.setSecurityManager, and you provide an instance of Security Manager. And then all of the classes that access critical resources such as files, sockets, class loaders, and all of that, they have a check that looks like this. So they simply check whether Security Manager is not null. And if it's not null, they're going to call a corresponding check method. For example, if we have a process builder class which executes operating system commands, before it's going to execute anything, it has a check. If Security Manager is set, we're going to call check exec, and we're going to pass the path to a file that we're trying to execute. If Security Manager finds an exception and says, oh, this is disallowed, it can throw a security exception, and the action is not going to be carried out. Really awesome facility. It's kind of like sandboxing built into the language. I've done on my blog a little survey, by no means a conclusive survey, but 27 people took it, and out of all of them, only 7 people were actually using a Java Security Manager in their application, and more than half they said they couldn't get it to work, or the performance impact was too high. So the question is, why no one is using it if it's so awesome and so great? It has several problems. First of all, it originally was designed to run untrusted code. And your application that you have created is not really untrusted code, right? It's a trusted code with potential for vulnerabilities. And because of the assumption that it's untrusted code, they have checks like this built into things you don't really care about. So every time you call system.getProperty, it's going to call into Security Manager. Every time you use reflection, it's going to call into Security Manager. Every time you create a custom class loader, it's going to call into Security Manager. So it adds up, and the performance impact, there was some research done, just one paper, but released by someone, very useless, because what they said is a performance impact from 2 to 100%. So from that perspective, depending on the policy and depending on how many rules you have, the impact on the performance can be quite significant. Another problem is that permissions are assigned by jars. So that means if you have a jar, say you have WebWork jar, and if OGNL was bundled into the WebWork jar, there is no way you could actually distinguish the two. You'd have to unbundle it, bundle it into separate jars, and that's how you assign privileges. Another problem is so-called privilege blocks, and several issues were discovered with that. I don't know, Sami Kovy, if you've seen a slightly different perspective, because he's attacking so-called applets, but he found some really amazing vulnerabilities with Java, where he was able to, in addition to finding a simple missing access context, he was able to align a bunch of objects in such a way and chain a bunch of calls in such a way that he would get elevated privileges. It's really good stuff. Now, so how do we solve all of this problem? Well, to solve all of this problem, what we can do in Java, as usual, we can extend the Security Manager class and create our own class, which will do things that we care about. So what are some of the things we don't care about? We don't care about class loaders. We don't care if your application is creating a custom class loader, because it's your application, it's your code. If they can create a class loader, they can, in applet mode, if they can create a class loader, they can assign arbitrary permissions to it. Since we don't care about class loader, even they cannot, we use our own permission model internally. We don't care if they're going to assign all privileges. We don't look at them at all. We're not going to care about do privilege block. We're not going to care about protection domains and all of this context. What we're going to care about is we're going to care about file access. And when I mean file access is reading files, writing files, executing OS commands. What we're going to care about is socket access, when you bind a socket, when you connect via socket. And we're going to care a little bit about reflection. And an additional cool feature that we're going to support is we're going to support ability to assign privileges based on class names. So if you want to assign one very sensitive permission, for example, one of your classes absolutely has to invoke bin sh using exec method, and I have seen that. If your code absolutely has to do that, what you can do is you can assign that one privilege to execute bin sh to only one class. And when Security Manager is going to be making checks and it's going to find, oh, someone's trying to execute code, it's going to actually inspect the stack trace and say, oh, is that class on the stack or not? The reason why we're going to care about reflection is because with reflection, you can actually disable Security Manager. So you can do things like this. In Security Manager, in using reflection, you can get a security field, because Security Manager is effectively just a private field on the system class. You can do that. You can make it set accessible. That means even though it's private, I want to still modify it and set it to null, and thus effectively disable Security Manager. So we're going to prevent that. What are the pros? So it addresses performance concerns, because now for things you don't care about, the minute the call into Security Manager is made, it immediately returns because it's an empty method, because we don't care about this. So that sorts out some of the performance issues. It solves the permission assignment problem because it allows you to do that by classes. And will detect interesting bugs, right? The bugs you care about, say path traversal vulnerabilities, code execution vulnerabilities like the one I showed you, external XML entity inclusion vulnerabilities, and etc. So it will catch all of those interesting bugs you care about. The problem is that it's not going to solve problems like this. So if you run an internet banking application and I'm an attacker and I download all of the jar files for your application, I reverse them, and then after that I figure out that you have a special class called banned transaction which encapsulates all of the RPCs and calling into the database and updating my balance. If I do this using the code that I can execute, if I do this, Security Manager obviously is not going to catch that. But the chances of the attacker triggering some alerts for you before he gets to that point is very high, because once you get the remote code execution somewhere, you want to make sure you actually have it. So you're probably going to go try to do ls somewhere, or you're going to try to do uname, or you're going to try to open etc password. And when you do it, you will have an alert for that. I've open sourced this code. It's right here. So if you use an application, you can try and give it a try and use it. Ideally, if we could work on making policy really nice and easy to do for standard engines such as Tomcat and JBoss, that would be great. And before we part, some ideas for you. So Java frameworks have been ignored for a lot of time, but Java actually now, more than Java, provides so many cool features that allow you to do instrumentation. It allows you to instrument classes after they've been loaded into OS, so you can do cool things like dynamic taint propagation and all of that. As far as I know, there are some companies that do that, but there is no open public implementation of this. And in addition to that, as you've seen, a lot of these vulnerabilities, they require you to have certain special set of characters in it. So what you can do is you can modify and instrument a string class after it's been loaded to always return true to whatever code is asking for. So if code is asking that the value is there is a substring like with slash or something like this, you can always return true and create such an object dynamically. So this way you can actually track how the input travels through the application, and it potentially can provide you a lot of clues with what's happening. Yep, and if there are any questions, I'll be more than happy to answer them. Sweet, thank you.
Thank you so much, Mila.